Hey everybody, Trey here. Welcome back to another video. It's been a long time since we last spoke. As many of you know, I've been out on my storm chasing tour guide gig, guiding those tours for the last couple months, so I just haven't had time to release a lot of videos, but today warrants a video for sure. So we're going to dive into the forecast for today's level 4 out of 5 moderate risk across the Red River region, southern Oklahoma into North Texas, including places like Turkey, Texas, over toward Lawton, Fort Sill, Wichita Falls, and down toward the Dallas-Fort Worth Metroplex in that level 4 out of 5 moderate risk for today. Level 3 out of 5 enhanced risk in the orange shaded region, all the way up from the Oklahoma and Texas panhandles, Amarillo over toward Woodward, southeastward, through the OKC Metro down toward the Arklatex region, Abilene, Lubbock in that enhanced risk as well, with a large slight risk extending all the way from the Mexico border, the Big Bend region of Texas, all the way up into Missouri and Illinois. So a broad severe weather threat today focused on the southern plains there in the enhanced and moderate risk areas, the orange and red shaded regions you see there. All hazards are on the table for today, but the greatest threat for today is significant damaging winds. That is the reason for the moderate risk. 45% hatched damaging wind potential percentages there in that moderate risk area. So that is in the pink stippled region with a large 30% hatched area in the red stippled region surrounding that. So broad swath of significant intense damaging wind gusts in excess of 80 to 100 miles per hour even for the storms this evening, especially as they congeal into an MCS. We're going to discuss why today's setup is so favorable for significant damaging winds here in just a bit. We also are going to have a large hail risk, 30% hatched area for large to very large hail in the red stippled region there. So the Texas and Oklahoma panhandles southeastward through much of Oklahoma into North Texas, OKC and Dallas, part of that as well. We do have a small 15% hatched area down there in the Big Bend region of Texas, including Fort Stockton, a couple storms possible down there, and a 15% hatched region for large hail extending up toward the Kansas City metro there in western Missouri. So we do have a broad swath of large hail that is possible for today. The tornado risk is going to be on the low side. SPC has a 2 and 5% region up there, with the 5% centered on the Oklahoma and Texas region. I don't believe today's setup warrants a really high tornado risk. The tornado risk should remain fairly low, and we'll tell you some of the reasons why that's going to be the case. But if we see some better, more favorable storm interactions, we could see a tornado or two out of the setup, along with a few tornadoes in the line as the MCS marches off to the southeast this evening. But overall, I think the tornado risk is going to remain very low, with the main threats being very large hail and damaging significant straight line wind gusts. So that is going to be the risks for today. Let's go ahead and take a look at the overall pattern here. Let's start at 500 millibars as we always do here on the SPC mesoanalysis page, and not a whole lot going on across the U.S. at this point. We see this closed low, this closed trough here, centered over southern Canada, dipping down into the northern plains. Strong jet streak rounding the base of that trough. Most of this is going to remain off to the north of our area of interest for today, but it is going to sag down to the southeast just a little bit, and we will see a little bit of a glancing blow from this trough, especially across northern portions of the risk area. Farther to the south, we see a little bit of ridging here across northern Mexico there. It has been somewhat de-amplified because of the incoming trough, but we still have a little bit of ridging there. In between the two, a little bit of a belt of slightly stronger flow across the southwest into the southern plains there. 30 to 40 knots of flow or so out there over New Mexico, Texas, Oklahoma. It's going to maintain itself today, perhaps strengthen ever so slightly as well, given the increasing pressure gradient here between the closed low to the north, the ridge of high pressure down here to the south. We may maintain that somewhat stronger belt of flow out across this region, the stronger westerly to northwesterly flow, which is a fairly classic setup for significant MCS activity, which is what we're going to have today. So not a ton of overall synoptic scale forcing for ascent other than this slightly stronger belt of enhanced flow there. Down at the surface, not much going on as well. We do have a strong surface low located up in Canada just off the screen here And going down to the south of that, we do have a little bit of a cold front. You see the pressure tongue there, cold front stretching down into the southern plains, definitely weakening with southwest extent. You don't really see those surface contours, surface pressure contours there, reflecting any sort of pressure tongue there in the southern plains as they do up here in the Great Lakes and Midwest. But still, we have a little bit of a weak gradient there, and that is going to be the main initiating boundary for storms today out across this corridor. Storms may start there up in the Oklahoma Panhandle, northwest Oklahoma, Texas Panhandle vicinity, and eventually will make their way southward. And a lot of storm interactions are going to allow for a fairly quick transition to an MCS today. And we'll show you another reason why we may have a lot of storms despite somewhat weaker synoptic scale forcing for ascent here in just a bit when we take a look at the soundings. Here is our surface map for this morning, most up-to-date surface data. You can see that wind shift and temperature gradient out across the southern plains there. You see the winds out across southwest Kansas into the Texas Panhandle out of the west there. In general, more southerly flow out here across Oklahoma, Kansas into North Texas. So definitely a wind shift in this vicinity. Temperature gradient is certainly there as well. Temperatures in the 70s out across Texas and Oklahoma. You move off to the northwest, those temps are in the mid to upper 60s there. So certainly a little bit of a temperature gradient. So the cold front looks to be somewhat in this vicinity right in here, right along that wind shift, somewhere there in northwest Oklahoma into the Texas Panhandle vicinity. And again, that's going to be our main initiating boundary for storms out here across this region. We should see storms develop there probably by early afternoon or so. As we have a very juicy air mass already in place along into the south of the frontal zone. You see temperatures in the 70s, dew points in the 70s across a broad swath here from Oklahoma down into Texas, so very rich moisture in place out across these areas. Now, this may not remain that way. We do see fairly clear skies out across the region for now. Here's our current satellite imagery. You see very crystal clear skies out here across Kansas and Oklahoma. A little bit of thunderstorm activity ongoing. We've had some pretty intense supercells out across West Texas this morning with some large hail, but those have since moved off to the southeast, and in their wake, very strong surface heating is already underway this morning. Recording this just after 8 a.m. Central Daylight Time. Strong surface heating underway out across these regions. So that may allow for some vertical mixing, and we'll talk about this here as we look at the soundings. So this is the current, the 12Z Fort Worth sounding that was observed here at about 7 a.m. Central Daylight Time this morning. Already pretty strong instability in place, about 2,100 joules per kilogram mixed layer CAPE. You see that already in place there. Very weak capping inversion in place just here, a little bit here at just above the surface. 80 over 72 at the surface, so rich moisture down here to the south. And again, those temperatures are going to rise pretty intensely this afternoon, getting into the 90s today. And with such strong surface heating, that may allow for vertical mixing. You see quite a bit of drier air aloft here, and that is going to perhaps get mixed down to the surface as we get that transfer of thermal energy, if you will. Vertical mixing, for those of you who are not familiar, that's when you have strong surface heating that allows air to rise at the surface. Well, as air rises, you also have a equal and opposite reaction, bringing air down from above. So that can kind of mix down some of this drier air aloft. You see the separation between the temperature profile and the dew point profile here. Very much a big difference there between the two profiles, indicating much drier air aloft. Some of that drier air may get mixed down to the surface. Another factor that this dry air may add to the environment today is allowing for much stronger downdrafts. So what happens here when you have a lot of dry air aloft is when you get storms to go, you'll have a lot of precipitation, but as that precipitation falls through this drier air, it starts to evaporate a little bit. And as that happens, when precipitation evaporates aloft, that can allow for those downdrafts that contain that precipitation to accelerate quite a bit toward the surface, allowing for much stronger winds to reach the surface. So that is going to perhaps allow the temperature dew point spreads at the surface to increase a little bit. Temperatures up into the 90s, dew points down into the mid 60s. So those temperature dew point spreads may get down into the make it up into the mid 20s or even higher. We'll have to just monitor that as we go into the afternoon. But high temperature dew point spreads mean high cloud bases and a better tendency for outflow. So strong outflow given strong high temperature dew point spreads there at the surface. So that is one factor here, allowing for some pretty strong outflow with these storms. Also, the drier air aloft, allowing those downdrafts to accelerate as they head toward the surface, allowing for stronger winds to reach the ground. So thermodynamically, we have quite a few factors today that are allowing for a pretty intense situation as far as outflow goes with these storms. Outflow should be very strong with these storms, even early on in the life cycle of these storms. Now, if we get those temperature dew point spreads pretty high, that's going to decrease the tornado risk as well. We do have kinematically a profile that is somewhat favorable for supercells here already. Effective bulk shear at 35 knots. Some little bit of low-level shear there. You see fairly weak winds in the low levels, but we do have quite a bit of turning of those winds in the low levels of the atmosphere, providing for slight curvature in the low levels of the photograph. That is expected to come down a little bit. You see the surface winds here kind of chaotic across this region, not really a focused surface pattern here, just 5 to 10 knot winds across a broad swath in many different directions here. So overall, a fairly chaotic, nondescript surface pattern today, and that should keep the tornado threat at bay alongside the fairly dry low levels and that transfer of strong outflow to the surface out of these storms. That will allow for more of a large hail and damaging wind risk with these storms, more so than a tornado risk. But when you have a weak low-level shear, you can overcome that through favorable storm interactions. We will have a lot of storms going up today, so if any supercells can interact favorably with one another, we could see a localized risk for a tornado or two, but overall I think large hail and damaging winds are going to be the main risk today. We should see this deep layer shear strengthen through the afternoon, allowing for storm organization. The deep layer shear should get up into the 40s and 50s knot range today, allowing for long photographs and organization of those storms and maintenance of those storms and storm clusters into the evening, providing for upscale growth and fairly rapid upscale growth given that we have a very weak cap in place. Strong surface heating, not really a focused surface pattern, is going to lead to a lot of storms. Despite weaker large-scale forcing for ascent, we should see a lot of storms go up at once, and that should be with such strong outflow. Congealing outflows will be a factor today, leading to a fairly quick transition to a more linearly organized complex here today. So that is at Fort Worth. The same thing at Norman. We even have some drier air there seeping into the low levels of the atmosphere. You see fairly dry air all the way up through about 300 millibars here. So again, that's going to be very favorable for strong outflow with the storms today across Oklahoma into Texas. All right, 6Z NAM here. Some model data for us. Recording this before the 12Z NAM is coming in. So but the 6Z NAM should do for our purposes here. So I'll fast forward it to 12Z this morning, so 7 a.m. this morning. That trough sagging into the northern plains there, strong jet streak rounding the base of that trough, that closed low up into Canada, centered right in there. And we have somewhat of that ridging there to the south, slightly enhanced belt of flow in between the two, going to maintain itself through the day today. Perhaps strengthen it even ever so slightly as that trough digs down to the south just a little bit. Strong belt of flow there by 21Z, 4 p.m. Central Daylight Time, impinging upon Texas into Oklahoma. So we do have a little bit of synoptic scale forcing for ascent here. But again, we are mainly going to be driving storms through the cold front, that weak surface front there across Oklahoma into Texas, as well as strong surface heating of that warm, moist air mass at the surface. Deeply mixed boundary layers as well. If we get those temperature dew point spreads pretty high, we'll have strong vertical mixing here that can deepen that boundary layer a little bit and allow for that cap to erode and storms to go up explosively this afternoon. So that will continue into the evening hours, strong flow across the region, but not a ton of change in the overall synoptic pattern for today. Let's go down to the surface here. Let me zoom into our Southern Plains sector here today. And again, fairly nondescript surface pattern at this point. Those surface winds fairly weak, fairly unfocused at this point. But we do have that slight surface reflection there into southern Kansas, northwest Oklahoma, Texas Panhandle. That will be our main frontal boundary for storm initiation this afternoon. You see temperatures warming very quickly across these areas. Up into the 80s. We know the NAM has a bias towards slightly cooler temperatures, so 88, 88, 87 there, 91 there in northern Oklahoma. You could add a few degrees to that. Low to mid 90s likely today across the region. In fact, let's go ahead and take a look at the forecast high temperature here to see what the NAM is going to show for these areas. Let's take a look at maybe Woodward as an example today. So it shows 87 degrees. I do think with southern extent down into the northwest Texas area, we are going to get temperatures into the 90s there with perhaps some mixing of the dew points. Let's take a look at the dew points here real quick. So we get that moisture up into Oklahoma and Texas for now. 70s dew points across Oklahoma down into Texas in the purple shading there. So ample moisture to start the day. But watch what happens here as we go into the afternoon. This is very interesting as we have a nice pocket there of dew points cratering into the 50s, even the low 50s there across this corridor of the Texas Panhandle into western Oklahoma. Now, is this convectively enhanced or is this vertical mixing? Let's go ahead and take a look at our convective precip signal. So here is that cratering, that area of cratered dew points there, right out ahead of where storms should be firing. This is by 21Z. Even by 18Z, we start to see that hole in the dew points right in there out across the Texas Panhandle. So let's take a look and see if we have any convective precipitation here. Looks like we do. So the NAM here initiating convection fairly early in this event. This is at 18Z, so 1 p.m., but we don't really see a ton of it. Maybe perhaps this just little blob of convection here on the NAM is allowing for off to the north a little bit of cratering of those dew points. And it is pretty significant. I would suspect that some of this is due to vertical mixing out across this corridor. As you see later on, we have more of those dew points kind of eaten out by the MCS. So the NAM certainly showing a signal for perhaps some convective contamination here, but also some vertical mixing across this corridor. Let's go ahead and take a look at a sounding from right in that area of cratered dew points there in the eastern Texas Panhandle. So, I tend to think this is a little bit of a model quirk. We are going to probably maintain quite a bit of instability here, even with strong vertical mixing. This low-level profile is quite weird, so somewhat of an interesting solution here on the NAM. Let's go back to the 0Z run just to see what it had, if it had the same thing. So it really doesn't have the same thing. Does have a little bit of those cratered dew points up across northern Oklahoma. We'll see if that's convective in nature, and it doesn't look like it. So the 0Z NAM might be a little bit more realistic here. Those dew points, pockets of those dew points cratering into the low 60s there. Again, temperatures getting up into the 90s. That's going to lead to high temperature dew point spreads and a tendency for outflow dominant supercells and outflow that will congeal and allow storms to coalesce into an intense MCS this evening. Downstream, though, of where storms are initiating, we do have some semblance of stronger moisture remaining, but eventually we will see these storms kind of congeal into a line and eat away at those dew points as the line sags to the southeast today. So interesting little setup here. Would like to take a look at a couple of other different models here. Let's take a look at the Euro model, see if it does mix those dew points out like the NAM was showing. This is going to be the 0Z run. Let's go back to the 6Z. That's actually the 6Z not quite out here on College of DuPage yet. So this is the 0Z run. 21Z, you do see some decrease in the dew points up here across the Texas Panhandle into northwest Oklahoma. You see those dew points now into the low to mid 60s, whereas they kind of start out in the mid to upper 60s here across this corridor. So some of our models are on board here with a little bit of vertical mixing out across this corridor. Let's take a look at the GFS as well, see if we have the same thing. And it looks like we do. You see there in the Texas Panhandle, northwest Oklahoma, those dew points are going to drop a little bit as we go into the afternoon today. Pretty impressive pockets of mixing there across northwest Oklahoma into the Texas Panhandle. So that is going to be where storms initiate first, leading to a pretty outflow dominant storm mode there with very early on in the life cycle of these storms. Any storms that can form in a little bit better moisture down in here would be more favorable for perhaps a low-end tornado risk and a slightly less outflow dominant character. But overall, storms expect to initiate farther north there in the drier air, leading to an outflow dominant mode pretty quickly in this overall setup. So we're going to stick with the 0Z NAM here, since the 6Z NAM perhaps is a little bit out to lunch with its solution for such strong vertical mixing here. But let me take a sounding from that mixed area in northwest Oklahoma at 18Z. We'll go to 21Z here and take a downstream sounding there where the moisture is. So you see here what this has done. You see that drier air aloft seeping down to the surface, 93 over 62 at the surface. Nice inverted V profile there in the low levels, indicating a drier low level air mass and that would lead to an outflow dominant storm mode. Also, this drier air helping to evaporatively cool those downdrafts and accelerate those winds and the downdrafts toward the surface for stronger outflow. But mixed layer CAPE still expected to be on the strong side, 2,000 joules per kilogram, especially where storms mix. We may see a little bit lower than areas in the lower CAPE than areas in the stronger moisture. You see here when our dew points are higher. You see here also at southwest Oklahoma, 97 over 70. Those temps expected to get pretty hot down there. Even if dew points stick around in the 70s, those spreads should be pretty high. But where your better moisture is also where your better CAPE is. 4,200 joules per kilogram mixed layer CAPE, very thick instability, leading to explosive updraft development likely along that weak frontal zone later this afternoon. And that should lead to pretty intense thunderstorm development. This is a pretty typical profile here for our region today. Again, where it mixes, we might see a little bit less CAPE, but still adequate for storm development, but more of an outflow dominant character with those storms there. And our hodographs, we'll go to our 21Z sounding there in southwest Oklahoma. You see our hodographs are fairly long, deep layer shear in excess of 50 knots, 0 to 6 kilometer shear there in the pink circle, 51 knots. So plenty of shear to organize these storms into initially supercells and eventually into a convective complex. But limited low-level shear. Again, very limited low-level winds there, 5 to 10 knots, maybe 15 knots at most there, all the way up through about 700 millibars or so. So very weak low-level winds. When you have this much instability near that freezing level, explosive updrafts, weak low-level shear, that is a good combination for large to very large hail. So large to very large hail, certainly a threat with initial supercells today before things congeal into a line, along with those strong downdraft winds. Again, tornado risk given the high temperature dew point spreads and the outflow dominant character of the storms that is likely. Weak low-level shear as well. The tornado risk is going to be on the very low side today, with especially with the initial storms. We could see a few going into the evening as the MCS takes shape. You see ahead of the MCS, this is going to be at 3Z tonight. We'll take a sounding right there just north of the DFW Metroplex, ahead of the convective line. And we do see a little bit stronger low-level shear there, with the evening soundings there still maintaining strong instability. Those cloud bases are lowered, but still with an MCS mode, that doesn't really matter as much. Plenty of instability there lasting into the evening. Somewhat stronger low-level shear, slight strengthening of the low-level winds there. And then you see our low-level shear vectors are definitely pointing toward the southeast. Our line is going to be moving off to the southeast. So a fairly line parallel nature to the low-level shear vectors. That is going to allow for a bit, perhaps a slightly higher tornado risk there. When you have your low-level shear vectors, generally your 0 to 1, 0 to 3, 1 to 3 kilometer vectors that are more perpendicular to the line, the movement of the line and the orientation of the line, that leads to a perhaps slightly higher tornado risk. So could see a few spin-up tornadoes with the line as it moves off through southern Oklahoma into North Texas near that Red River vicinity, over toward the Dallas-Fort Worth Metroplex tonight. But overall, the main threat is going to be damaging winds with congealing outflows. Again, all those factors we talked about: dry low levels, dry air aloft, leading to evaporative cooling, strong instability leading to explosive updrafts and downdrafts, and the tendency for outflows to congeal with time, and strong deep layer shear to allow for the organization of storms into an MCS. That is going to, all those factors contributing to very strong winds reaching the surface with that MCS, 80, 90, even 100 plus mile per hour winds possible this evening in some of the localized higher gusts. So very intense MCS. As far as whether or not this is going to be classified as a derecho, we'll already have received a few questions about that. It's just going to depend on how long this lasts. You can see downstream of where the MCS would be by this evening. This is at 3Z, so 10 p.m. tonight. You see a very lengthy corridor of strong enhanced moisture there for these storms to continue to plow through their parts of East Texas going into the evening hours. Could see that last over into Louisiana, so just going to depend on how long it lasts before the significant wind gusts subside. Could eventually be characterized as a derecho, just based on how long it lasts. So overall, a very potent setup for today for significant damaging winds. Again, maybe a few spin-up tornadoes within the line and large hail very, very early in the convective life cycle today. So let's take a look at a couple of cams here. So this is our 12Z HRRR. So you see the initial activity across northwest Texas subsiding with time. And then when we go into the afternoon, we see pretty rapid development. This is at 19Z, 2 p.m. Central Daylight Time, initiation there up in the Oklahoma Panhandle vicinity. And then we get a lot of storms to fire pretty quickly by mid to late afternoon, and then they all kind of cluster up and congeal in and become a very significant line of storms moving through the Red River region going into the evening hours. Very robust looking sort of bowing segment there out across this corridor with intense damaging wind gusts. I'll show you actually the damaging wind gusts. You see, first, though, you see that this does last for quite a while into perhaps Louisiana before it subsides. So that's definitely could be classified as a derecho when things are all said and done. But let's go ahead and take a look at the surface wind gusts. If we take a look at the HRRR's wind gust plot here, you can see within the line you see some of those yellow colors. That's some pretty intense wind gusts there. 75 knots being registered there. This is on the College of DuPage HRRR product here. 75 knots, that's upwards of 80 plus miles an hour there. So very intense wind gusts within the line that tracks toward the DFW Metroplex eventually. Some of those very strong wind gusts there. You see some 90 knot readings, so very intense wind gusts possible within the MCS. And that is going to lead to straight line winds, even though we're not talking about a significant tornado risk. Some of those 90, 100 knot wind gusts, even in a straight line capacity, are going to have the potential to produce some pretty intense damage there. So folks in that southern Oklahoma, North Texas corridor definitely need to be on alert for some significant straight line wind gusts as this MCS moves through. So overall, very impressive looking MCS. Looks likely this afternoon into the evening with all those factors that we talked about. So let's go ahead and take a look at the 0Z cams here. Just want to show you a couple different solutions. The 12Z cams, the ARW, the NSSL WRF, not quite in yet, but should be good enough to show you at least an estimate for some of these other models. So you see quite a bit of activity there, and then we get a pretty robust MCS moving through that corridor by the evening. Perhaps some lead supercells here on this model down in the Red Rivers vicinity initially compared to the HRRR, which was mostly up in here. So that has a possibility as well. Still, I think large hail and damaging winds going to be the main threats with those, and then with that MCS moving through, definitely Dallas-Fort Worth Metroplex, everybody in the DFW Metroplex should be on alert this evening for significant straight-line wind gusts. 0Z NSSL WRF model, just another one of our models we like to use. This was the overnight convection, and then we get this afternoon and a rapid upscale growth into a very intense bowing MCS there through North Texas. So all in all, very impressive look on all of our models here for an intense MCS moving through southern Oklahoma and North Texas going into the evening hours tonight with intense 80, 90, 100 mile per hour wind gusts possible within the line, especially where any of these line segments start to bow outward. The apex of those bows could lead to the strongest wind gusts within the line. All right, so that's going to wrap things up for this video today. Again, a very potent setup on tap for parts of the Southern Plains. SPC has a moderate risk level 4 out of 5 in the red stippled region there today. So Southern Oklahoma, the Southeast Texas Panhandle into North Texas. Lawton, Fort Sill, Wichita Falls over toward Ardmore, Dallas-Fort Worth, all the entire DFW Metroplex in that level 4 out of 5 risk. Level 3 out of 5 enhanced risk also could feature some significant severe weather there in the orange shaded region there. The Texas Panhandle, Oklahoma Panhandle, Amarillo, Woodward, Guyman, southeastward through Oklahoma City, Norman, over toward the Arklatex region, Abilene, Lubbock, also in that level 3 out of 5 risk. And then a slight risk extends up along the frontal zone into Missouri and Illinois. Some stronger storms with some large hail and damaging winds possible up there. And then also an area down in the Big Bend region of Texas could see a few storms with significant severe hail and damaging winds down there. But the main threat going to be in the orange and red shaded regions there today. That is mostly Oklahoma into Texas, and that could eventually be extended southeastward into at least the enhanced risk down into parts of Louisiana, depending on how persistent that MCS is overnight. All hazards in play for today. Again, the main threat's going to be large hail, significant large hail possible, particularly in the 30% hatch region, and will be maximized with any more isolated supercells in the early convective life cycle before things congeal into a line. Also, some large hail expected from Fort Stockton southward into the Big Bend region, also along the cold front to the northeast, up into Kansas and Missouri. But damaging winds going to be the main story for today, damaging straight line winds with the MCS later on, and really in any supercells as well, given the outflow dominant nature of the supercells that is expected, but really especially as things congeal into a line and move off into the Red River region tonight. 45% hatched region in the pink shaded region there for significant straight line damaging wind gusts. Could be in excess of 80, 90, 100 miles per hour with some of these gusts in the MCS later this evening. 30% hatched region does cover Oklahoma City and Norman, so could see some strong wind gusts as well, but very potent winds expected with these storms and the MCS tonight. As we discussed, the tornado risk is on the low side. They do have it at a 5%. Any favorable storm interactions could help overcome the limited low-level shear. But I think the outflow dominant nature of the storms today and the quick transition to a more linear mode will lead to more of a damaging wind and large hail risk, and then especially a damaging wind risk as the MCS moves off into the Red River region. Could see a few spin-up tornadoes along the line given the line perpendicular flow, especially the low-level shear vectors relative to the orientation of the line. Could be favorable for a few spin-ups as it moves off to the east, especially with any Boeing segments there. But overall, I think the tornado risk is going to be overshadowed by the damaging straight-line wind risk, given all the factors that we discussed in the video today. So, folks here in Oklahoma, Texas, especially, definitely be on alert, high alert, have multiple ways of receiving warnings. And keep in mind that straight-line winds can be just as destructive as tornadic winds, especially with a strong MCS moving through like the one that is expected tonight. So that's it for this video. Thanks for watching, and we'll see you next time. Thank you for watching this forecast discussion. I hope you found it helpful. If you'd like to access more free content, head over to stormchasercoaching.com and click on the free button in the menu. There are ebooks, podcast episodes, and even a free community that you can join to connect with weather enthusiasts and storm chasers just like you. The link is in the description box below. Thanks again for watching.